Hello, my name is Yoshihiro Katsura, and I'm a board-certified orthopedic spine surgeon practicing in Northern California. Today I'd like to discuss how pain works in our bodies and how our bodies process pain. Pain is the number one complaint that I see in my office as an orthopedic spine surgeon, and probably the number one reason why someone would choose to come visit a spine surgeon. I think most people's understanding of pain is that it is something that is universally bad. And that's understandable. It's obviously very unpleasant. It can totally interfere with your quality of life and impact the way you enjoy doing your various activities. But I think it's really important to remember that you could not survive without pain. In reality, pain is one of the most important defenses that you have against tissue damage or harm to your body. Pain is somewhat of an early warning system that lets us know that something bad is happening to the body. Without pain, we'd have a hard time knowing if we were too close to a fire or if we were doing some kind of ongoing damage to our bones and joints. It basically keeps us from hurting ourselves. I think it's helpful to think of pain as a sense as opposed to a symptom. If there is a lot of stimulation, obviously pain can be very noxious and not very tolerable, but at low levels it's pretty manageable. And it's similar to if you're looking at a very bright light, how you have to turn your eyes away to avoid damage to your eyes, or if you're listening to a very loud noise, you might cover your ears. Too much pain is obviously very difficult to deal with, but the reason that I know that pain is not entirely bad is that in some instances it can be good, such as after performing exercise, which at times can be painful. We interpret that as being something that's good for our bodies, and it can actually be somewhat of an enjoyable experience. Another thing I find very interesting about pain is that there is no diagnostic test, at least none in existence yet, that can tell exactly where the pain is coming from in a patient or how much pain that person is having. Pain is basically a subjective experience that's different for everybody. So let's jump right in and start understanding how pain works in the body. To understand pain, you have to understand a little bit about the anatomy of the human nervous system. The human nervous system basically consists of a peripheral nervous system and a central nervous system. The central nervous system consists of the brain and spinal cord, and the peripheral nervous system consists of the nerve bundles that exit from the spine and travel through your arms and legs. The entire nervous system is composed of a small subunit called the neuron, which is a very long cell that acts as almost an electrical wire in the body, and it's able to transmit a chemical signal from one end to the other, and is a pretty miraculous structure. So how do neurons work? And you have to remember that there are trillions of neurons throughout your nervous system all doing this. What happens is a neurotransmitter, which is a chemical signaling molecule, comes into contact with one end of the neuron called the dendrite, and that causes what's called a depolarization in the neuron cell, which essentially is a chemical change that is transmitted from one end of the neuron to the other end of the neuron, and signals that the neuron should then release even more transmitter. Neurons are all linked in series, and that's where the neurotransmitters come from. Is one neuron connects to the next neuron, releases neurotransmitters, and causes the next neuron to activate and then release more neurotransmitters. And you can have excitatory or inhibitory neurons connected to a single neuron, which means that some neurons activate the neurons and some neurons actually inhibit the neurons. Whichever nerve is stronger and causes more action within the neuron develops a stronger connection with that neuron, and that's how new processes are learned in the nervous system. So how does this all connect with how pain works? Well, we know that the neurons are all connected and that the chemical signal from one end of a neuron is transmitted to the end of the neuron, and then that can be crossed over to the next neuron, and that's how these impulses travel through our bodies. One of the most basic theories of pain is called the specificity theory. And what this means is that there's three different neurons organized throughout our nervous system. There's the peripheral neuron, a spinal cord neuron, and then a neuron in the brain. And so the peripheral neuron is the neuron that's responsible for actually sensing the pain. So that's where if you cut your finger, the peripheral neuron would sense that there had been some damage, transmit a signal up to your spinal cord. Your spinal cord would then relay that signal up into the brain that would interpret it as the sensation of pain. That's the most basic understanding of pain that we have. So let's just think about that again with the cartoon of the nervous system here. We have the brain, the spinal cord, and the peripheral nervous system that connects to the hand. If there's some kind of pain stimulus like getting stuck by a sharp needle, the pain stimulus travels through the peripheral neuron up into the spinal cord, which you can see here, and then in the spinal cord it's transmitted all the way up into the brain, and that's where you experience pain in your hand. But the specificity theory is really too simplistic and can't be used to explain a lot of the different phenomena that we know occur with pain. One is that from a neuroanatomical perspective, pain travels not just to one area. It doesn't just go to the hand area or the thumb area, but it actually goes throughout your entire brain. We also know that you may interpret the exact same pain signal differently based on the context. And I can think of this like going for an exercise run. You might experience a burning sensation in your legs from lactic acid, which may feel good if you like running. But if you burn yourself, that will actually feel bad. So a burning sensation in that case does not feel good. We also know that everyone experiences pain slightly differently, and so the analog or one-to-one ratio of pain experience that's described in the specificity theory really does not explain that. We also know it's possible to ignore or even suppress pain, so the specificity theory doesn't explain that either. So let's dive a little bit deeper and learn a little bit more about the neuroanatomy and how pain works in the brain. So as I explained earlier, pain is not just connected to one area in your brain. The pain that you experience travels up the spinal cord and goes to a lot of different areas in the brain. And the three main areas that is connected to are the limbic system, which is responsible for how we experience fear, the thalamus, which is the sensory system, so that would be how you would localize where your pain is coming from. So that's how you would say, oh, this pain is coming from my hand. And finally, the cortex, which is involved with memory and your conscious experience of pain. So the different areas in your brain are all connected and talk to one another and create what's called the neural matrix experience of your pain. So that's how we attach complex behaviors and interpretations to our pain, is through the filtering of pain signals in these various areas in our brain. So if we were burned in the past and have a memory or even active injury from that burn, we may be very afraid to come close to a fire and may change our behaviors to avoid being burned in the future. That's your neural matrix at work. A more modern framework or theory that we use to describe pain is called the gate control theory, which you may have heard of. It's also called the neural matrix theory of pain, as we described earlier. So in the gate control theory of pain, it's not a single linear 3-neuron system, but a multi-neuron system. And you can see that the pain fibers connect to the spinal cord neuron that then is transmitted to the brain, but there are also these large sensing fibers or fibers that are responsible for the transmission of touch that connect to the spinal cord neurons and actually can inhibit the pain signals that are transmitted to the brain. In addition to this, you can see how the brain has descending fibers that synapse with the spinal cord neurons to actually inhibit pain as well. So I remember when I was a little kid, and anytime I fell and got hurt, my mom would told me to rub the area, and that would somehow make it feel better. And it turns out that there's actually a lot of sense to that. What you're doing when you rub the area is activating the large fibers or the touch fibers that inhibit the signal for pain. And so there is a rational neuroanatomical explanation for why that works, and it's explained by the gate control theory. And by someone comforting you and telling you that it's okay, you are actually activating your descending inhibitory pathways that block the pain experience. So just to summarize, we know that the brain is always filtering and selecting and modulating the pain inputs that it receives. Other sensory inputs can actually suppress the pain, and the brain has the capability of suppressing the pain directly itself based on the gate control theory. The neuromatrix creates a neurosignature, and that's essentially how we feel or how we experience pain. And the inputs for this are sensory, pain and touch, memory and emotion, which can charge pain or amplify it or decrease it. And then the outputs are our perception, our actions and behaviors, such as staying away from triggers that may have caused us pain in the past. So the pain system really is a very elegant system in our bodies. The pain comes in, and we know that there's this linear relationship where it travels up the spinal cord into the brain, and that lets us know that something bad is happening. There is a pain going on here. In the gate control theory of pain, the pain can travel unobstructed up into the brain and cause an experience of pain in the brain, but the gate can also be closed, and that stops the stimulus from occurring and stops the brain from interpreting the pain as severely or even noticing it at all. So I don't know if you've ever been injured or had this experience, but you may have an injury and then you're focused very intensely on your pain that you're experiencing, but then maybe sit down and watch a movie, and you get engrossed in watching the movie or get distracted somehow, and you notice that your pain, you're not even thinking about it at that time, and that's explained by the gate control theory of pain because of this descending inhibitory pathway that we have built into our bodies. So, in summary, pain is a really complex but very elegant defense system that we have for the body. Too much pain is obviously very noxious and uncomfortable, and we want to avoid that. But not having pain at all is dangerous and not compatible with survival. Our other sensory systems can modulate pain, so touch, vision, sounds, things like that. They can actually activate your brain and activate the descending pathways that can inhibit pain. And this is a really powerful concept, I think. Pain can be modulated or quieted, so the context that the pain is occurring in, your thoughts and the memories that you have can modulate or amplify the pain that you're having. They can also be used to suppress pain, and this is important knowledge to have with regards to how we live our lives. So if you like this video, you can subscribe. I think I'll do further videos in the future talking more about pain and spinal problems.